Okay, here we go. Today's lesson is on differential equations and applications. This is on page 470 in your brief calculus book. For a function y equals capital letter f of x, then dy dx is little f of x, and that's considered the differential. So your first examples are fairly easy, and your last two are with word problems, which make it a little bit more challenge, but I think you can handle them. All right, so we're going to solve the differential with boundary conditions of y equals 5 and x equals 3 for dy dx equals 5x squared plus 2. Note the original equation is the blue equation. The pink is I added in. So what do you need to do? You need to, number one, integrate. Number two, solve for k. And there three, write the equation with k from your solving. Very similar to what we did last chapter. So we integrate 5x squared is now 5x cubed over 3. 2 is 2x plus k, and dy dx becomes y. So you now have y equals 5x cubed over 3 plus 2x plus k. You put your numbers in, solve your numbers for y equals 5, put 5 in. You put your 3 in for x, 5 times 3 to the third over 3, plus 2 times 3 plus k. Notice I canceled out this 3 with that, so I made it 3 squared. 5 times 3 squared is 45, plus 2 times 3 is 6. 45 plus 6 is 51 plus k equals 5. Subtract the 51, k equals negative 46. Go back to your equation, substitute in k, and you're almost done. So you have y equals 5 times x cubed over 3 plus 2x minus 46. Answer. All right, we'll do the second equation. Solve the differential with boundary conditions of y equals negative 1 and x equals 3. For x squared plus 2x plus 1 is your dy dx. So you have to integrate to get your y. X squared integrates to x cubed plus 3. 2x is 2x squared over 2 plus 1x plus k. Substitute if we're following the same steps. You substitute negative 1 and 3 in. Negative 1 equals 3 to the third over 3 plus 2 times 3 to the third over 2 plus 1 times 3 plus k. Sorry about that. The 2's cancel. Notice I cancel one set of 3, so I get 3 squared, which is 9. 3 squared again, which is 9, plus 3 plus k. 9 plus 9 plus 3 plus k is 21 plus k minus 21. Negative 1 and negative 21 make negative 22. So k equals negative 22. You put that back into your equation. Y equals x cubed over 3 plus x squared plus x minus 22. Now the rest I'm going to say, this next part is going to be some definitions and things you're going to use for your word problems. So you need to write this down before I get to the next board. All right, so this is on applications, which is going to be a definition and a formula. This is important. The amount A of a substance varies with time t in such a way that the time rate of change is proportional to A itself. That's the key thing. It's proportional to A itself. So I'll give you a minute to write that down. It's also on the bottom of page 471 if you'd rather read it from there. The formula, dA dt, is your differential equals k times A. When you get that out, you get A equals A sub 0 e to the kt. This formula is going to be noted, and we're going to use different variables in there, but it's definitely going to be used in the next two examples. A equals A sub 0 e to the kt. E is going to be that E button on your calculator. You're going to need your calculators for this. All right. Let's move to next board. And on the next board we have a word problem. And it says, assume that a population of a colony of bacteria increases at a rate proportional to the number present. If the number of bacteria doubles in 5 hours, how long will it take to triple? The book suggests dn dt equals a times n, whereas we had dA dt equals k times a before. So, oh, that's a k times n, my bad. So the formula would be, if we choose n's instead of a's, it's going to be n of t equals n sub 0 e to the kt. I just exchanged n in for a, nothing else. So write your formulas down because that's what you're going to put your concepts into. So you need an n sub 5 equals 2n, so because n at 5 hours, it doubled, 2 times n. So when I go over to here, my n of t, I'm going to have 2n sub 0 equals n sub 0 e to the k times 5 in pink. I chose to divide out the n sub 0s. I get 2 left in orange and e to the 5k. You can natural log both sides to get rid of your e. Notice over here I wrote cha-ching. Natural log your both sides, so your natural log of 2 is 0.69314. The e in the natural log, because the base is e, it eliminates and you get 5k. You divide by 5 and you get 0.69314 divided by 5 is 0.1386 equals k. So all you've done is solve for k. You have not found what it does to triple. So you have to put the k now back into the original equation and finds out when it's triples. So instead of 2n sub 0, you're going to do 3n sub 0 for triples. Equals n sub 0 e to the kt, e to the 0.1386t. So you always have to find k first. I believe we did this when we did natural logs to a certain extent. You divide out your natural log, or your n sub 0s, and you get a 3 and e to the 0.1386t. You natural log both sides. The natural log of e cancels out. Cha-ching. Natural log of 3 is 1.098612 equals 0.1386t. Divide by 0.1386 on both sides, and you get 7.926 hours to triple the number of bacteria that you have. So that's the answer for example 3. All right, example 4. In the skull of an animal found in an archaeological dig, it was determined that 20% of the original amount of carbon-14 was still present. Hope you guys have some biological background here. If the half-life of carbon-14 is 5,600 years, find the approximate age of the animal. So this time we decided to use the A formula. I'm not sure why they use the N formula there. It makes no difference. So dA dt equals k times A, and A of t equals A sub 0 e to the kt. Well, what do you know? What I highly suggest, especially when you're doing these problems on your own, is what two things go together. Does the 20% go together, or does the half-life with the 5,600 years go together? Well, the half-life with the 5,600 years went together. I would underline that if I was taking a test. So the half-life is what we don't know. Half-life of A sub 0 equals A sub 0 e to the k times 5,600. Half-life, 5,600, I have two things in that formula. If you use the 20%, you would have not had two things. You would have had k times t, and you would have been lost. So one more time, I had half-life and 5,600. So half-life of A equals A sub 0 e to the k times 5,600. Again, you divide out your A sub 0s. You get E equals e to the 5,600k equals 1/2 in orange. You natural log both sides. The natural log of 1/2 is negative 0.69314. You cha-ching here, you cancel those out, and you get 5,600k. You divide by 5,600, and negative 0.69314 divided by 5,600 is negative a big decimal, negative 0.000012397 equals k. That is what I put in to my k. Note, if you don't put enough decimals in there, if you only use 3 decimals, you would have 0.000. You can't do that. You at least have to have 3 significant zeros, or 3 significant places. So I put in the whole thing. So I put in that, and I need 20%. That was the whole question. How much at 20%? Or how long? So you have 20% of A equals A sub 0 e to the negative 0.00123997 t. Divide out the A sub 0. You have 0.20 equals e to the negative 0.000123997 t. You natural log both sides. You have natural log of 0.20 is negative 1.609437 equals negative 0.000123997 t. Divide that out. Divide a negative divided by negative, you get your positive. Negative 1.609 divided by negative 0.00123 is 12,982.479 years. Time it takes. So I really like this kind. All right, your assignment is 6.7. You don't have very many word problems, so don't get scared. You have more like page 1. Page 476, 1, 5, 6, 7, 9, 10, 11, and 13. There you go. All right, that's all we have for 6.7. Nice short lesson. Hopefully that makes it easier for you. And let's see if I can get this to go off. There we go. Maybe.